we're asked to graph the circle, and they give us this somewhat crazy looking equation, and then we could graph it right over here. And to graph a circle, you have to know where its center is, and you have to know what its radius is. So let me see if I can change it. And you have to know what its radius is. So what we need to do is put this in some form where we can pick out its center and its radius. So let me get my little scratch pad out and see if we can do that. So this is that same equation. And what I essentially want to do is I want to complete the square in terms of x and complete the square in terms of y to put it into a form that we can recognize. So first let's take all of the x terms. So let's take all of the x terms. So you have x squared and 4x on the left-hand side. So I could rewrite this as x squared plus 4x. And I'm going to put some parentheses around here because I'm going to complete the square. And then I have my y terms. I'll circle those in, well, the red looks too much like the purple. I'll circle those in blue. Y squared and negative 4y. So we have plus y squared minus 4y. And then we have a minus 17. And I'll just do that in a neutral color. So minus 17 is equal to 0. Now, what I want to do is make each of these purple expressions perfect squares. So how could I do that here? Well, this would be a perfect square if I took half of this 4 and I squared it. So if I made this plus 4, then this entire expression would be x plus 2 squared. And you can verify that if you like. If you need review on completing the square, there's plenty of videos on Khan Academy on that. All we did is we took half of this coefficient, and then squared it to get 4. Half of 4 is 2, square it to get 4. And that comes straight out of the idea. If you take x plus 2 and square it, it's going to be x squared plus twice the product of 2 and x plus 2 squared. Now, we can't just willy-nilly add a 4 here. We had an equality before, and just adding a 4 wouldn't be equal anymore. So if we want to maintain the equality, we have to add 4 on the right-hand side as well. Now let's do the same thing for the y's. Half of this coefficient right over here is a negative 2. If we square a negative 2, it becomes a positive 4. We can't just do that on the left-hand side. We have to do that on the right-hand side as well. Now, what we have in blue becomes y minus 2 squared. And of course, we have the minus 17. But why don't we add 17 to both sides as well to get rid of this minus 17 here? So let's add 17 on the left and add 17 on the right. So on the left, we're just left with these two expressions. And on the right, we have 4 plus 4 plus 17. Well, that's 8 plus 17, which is equal to 25. Now, this is a form that we recognize. If you have the form x minus a squared plus y minus b squared is equal to r squared, we know that the center is at the point a comma b, essentially the point that makes both of these equal to 0, and that the radius is going to be r. So if we look over here, what is our a? We have to be careful here. Our a isn't 2, our a is negative 2. X minus negative 2 is equal to 2. So the x-coordinate of our center is going to be negative 2, and the y-coordinate of our center is going to be 2. Remember, we care about the x value that makes this 0 and the y value that makes this 0. So the center is negative 2, comma 2, and this is the radius squared. So the radius is equal to 5. Radius is equal to 5. So let's go back to the exercise and actually plot this. So it's negative 2, comma 2. So our center is negative 2, comma 2. So that's right over there. X is negative 2, y is positive 2, and the radius is 5. So let's see, this would be 1, 2, 3, 4, 5. So you have to go a little bit wider than this. My pen is having trouble. There you go. 1, 2, 3, 4, 5. Let's check our answer. We got it right.